Hello. We're going to take a look at baseball, my sport, and the physics in baseball. This has been a pretty interesting course for me, and I've known a lot of these things to play its role in baseball. However, looking at different parts of baseball and analyzing physics and actually looking at how physics, plays in certain aspects of the sport has been a real eye-opening thing for me. So, with that said, I'm going to play a bunch of clips here of professional baseball players as well as some of my son Evan, and we're going to look at how physics works in these scenarios. And I'll most particularly be examining Newton's law, friction, velocity, acceleration, and speed, and how they play a role in baseball. One of the things that I find interesting in baseball and baseball history per se is how the game is evolved over time. And it's played, even though it's similar, it's played much differently than it was, say, 80 to 100 years ago. Yes, baseball is that old. And one of the names that you always hear when you're talking about hitting in particular and home runs, one of the names is the great Babe Ruth. We know that he was for the longest time, was the person that had the most home runs in baseball. I think, without doing a quick Google search, I think he either hit 713 or 715, somewhere up there. And of course, his record has been broken since, first by Hank Aaron and then by Barry Bonds. However, I think Babe Ruth is interesting because of his swing and his mechanics. What physics has to do with this is interesting because, as you see here in this clip right here, the fundamental way that Babe Ruth stands is just not a common way that you would see baseball hitting stances nowadays. He's got his feet together. He is kind of hunched over, and though each baseball player kind of has their own stance and their own style, this is a stance that is particularly odd to me because usually we see baseball players with a more wider stance, and their feet are not together and they're not so hunched over like this. So for the physics, we'll take a look at Babe Ruth's swing here, and then I'll analyze the physics of the swing. Again, it's a very interesting type of swing. He keeps all of his weight back and then kind of lunges forward, almost like a softball, like a slow pitch softball swing. In any case, analyzing, this in terms of physics is we have the weight of the bat and the weight of the ball. In Babe Ruth's case here, he's using a heavier bat than they use nowadays in baseball, probably by about 12 to 15 ounces. I don't know exactly how many ounces the bat was, but I know it was quite more than they use nowadays. I'm not sure how it's probably the baseball that they used in the 20s and 30s is probably a little bit more similar to the baseballs that they use now. And so we have the speed of the swing. We have the force, and of course we have Newton's second law in here. When Babe Ruth makes contact with the ball, he sends the ball into another direction, obviously. Newton's second law of motion pertains to the behavior of objects for which all existing forces are not balanced. The second law states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. So here we have a force acting upon the baseball, and we have a baseball that is quite smaller than the bat, obviously, and you have the contact and the collision sending the ball forth. Okay, moving on, I wanted to take a look at the Reds, and one of my favorite players on the Reds right now, and I think one of the most talented that many people would agree with, is Billy Hamilton. So we're going to take a look at his acceleration, his speed, and sliding. We talked about sliding in one of my earlier videos with Evan as demonstrating that slide. And we're going to see Billy slide here. Of course, he's using a head first slide and not a more traditional slide, on the rear end with his hands up, as again we did with my son Evan. But so friction is important here. His acceleration off the bag, right there, his speed, and then his slide. And he has to calculate all this at a perfect time. And as you see here in this slide, friction being his mass of his body rubbing against the ground, rubbing against the dirt. And if there's no base there, eventually he's going to stop. But he's calculated it in a particular way while he's running, and he's able to use the earth and use his friction to get to the bag at a perfect time to beat the throw and to make it in there safe. Now we'll take a quick look at Evan pitching here. This is Evan pitching at practice. And we're also still going to talk about friction, and we're going to talk about velocity. And it's also interesting to note that if a person was standing and just kind of making a vertical circular motion with their arm, and they had a ball in their hand, and they released the ball is going to go obviously in a straight line from where they released the ball. We know this in physics. Not so with pitching, and this is interesting. As we see here, Evan will pitch, and it's not a straight line. Evan's pitch is Evan's pitch is dependent on a number of variables, but one thing that I find that's interesting with pitchers in Major League Baseball is they're able to manipulate their motion of their arm, and they can use they use the friction of the air. Let's take a curveball, for example. Curveballs are not straight pitches. They move. They move in the air, and they fool batters. I'm thinking of knuckleballs and changeups as well. And so the ball will use the friction in the air as it's traveling, and it can be manipulated to fool the batter or to take the batter off of his game. And last but not least, I have to throw in the Cincinnati Reds. I'm old enough to remember this play right here. And this is the year that they won the World Series. Unfortunately, it was long ago. We're ready for another one. But we see a ball in motion and then a ball stopping right there as that last final play is caught. And so this has been my physics demonstration. This is the Reds winning the World Series. And I hope that I've demonstrated well good examples of Newton's second law in particular, all of Newton's law: friction, velocity, acceleration, and speed.